We want to look at introduction to polynomials. Mind you that polynomial could be given in any form, as in any variable. It could be given in terms of x. It could be given in terms of y. What is given to you is what you use. But a polynomial basically is a finite sum of terms, a finite sum of terms. So let me put it this way, that polynomial in x, that is in the variable x, is a finite sum of terms of the form this form here. So a polynomial is of this form. And don't freak out. This is just a generic way of writing a polynomial, where the a, this is an here, sorry about that, an, the an sub 1, and these are said to be the coefficients. Now the coefficients of the terms of the polynomial. The n that you see there, the n there is said to be the degree. It's the degree of the polynomial. The whole of an here is said to be what we call the leading coefficient. And xn is said to be, is also known as the leading term. The leading term. Okay, so that is how, you know, a polynomial is expressed. And do not freak out, is very, very, very easy. A typical example is, let's say I give you 2x5 minus, let's say 3x4 plus 2x cubed minus 4x squared plus 2x plus 1. This is a typical polynomial expression. It's a typical polynomial expression. And the fact that it is defined as the finite sum of terms. Doesn't mean that you're going to have plus, 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 plus all through. No, it could be a minus, it could be a plus. After all, we can rewrite a minus in terms of a plus, so don't freak out about the definition, and don't freak out about the generic way of writing a polynomial. In this case, 2x raised to the 5th power, this is the leading, that's what we call the leading term. It's a leading term. The 2 there in front of the x is the leading coefficient. Leading coefficient. And the 1 here, this last term here, the 1 is the last term. Okay, so basically this is a typical example of a polynomial. Now there are 3 unique, types of polynomial, or 3 common types of polynomial. Let's talk about the common types. Polynomial. We have what we call a monomial. So that's the first one, a monomial. This is a polynomial with only one term. Then we have a binomial. That is a polynomial of 2 terms. Polynomial of 2 terms. And then we have a trinomial. Polynomial made up of 3 terms. Okay. So these are the 3 common types of polynomials. An example will be for the monomial, you have something like 2x cubed. This is a monomial. You can have 4x, it's a monomial. If you have -2, it's still a monomial. And then with a binomial, something with 2 terms. So let's say I can combine these 2 here, will be 2x cubed minus 4x. This is a binomial. Or you could have x squared plus 1. This is still a binomial. And then we have the trinomial. We have something like x squared minus 6x plus 9. It's a trinomial. You could have x cubed minus 2x squared, plus, let's say 3. This is also a trinomial. So these are the various types of, polynomials that we could have. Okay. Now, any other polynomial is just generalized as a polynomial. Okay, so any polynomial that does not have one term or two terms or three terms, but you have more terms in them, is just simply a polynomial. So think of, the definition of a polynomial. Definition of a polynomial says that it is just a finite sum of terms. Finite sum of terms. So what is a term? So let's look at what a term is. Now, a term is, so this is, could be a number, a variable, the product of a number and variable or variables, raised to some power. Okay, raised to some power. So that would be a term. So example would be, if you have 4, if you have -3, if you have 2x, if you have -5x squared, or you could have 6xy squared. These are all terms. These are all terms. So they could be numbers. They could be the product of a number and a variable, or one with a number and a variable, with the variable squared, or with a some power, or you could have that with, multi-variable in that term. Okay. Then we can talk about what a coefficient is. Coefficient. Coefficient is simply a factor. This is let's put it this way. This is just a factor or a number that multiplies a given variable. Or simply put, the number before a given variable. Okay. The number before a given variable. So for instance, if I gave you the coefficient of -3x to the third is -3, because it is the number that comes before the variable. So it's a factor or a number that multiplies a given variable. If you have x squared, the coefficient there is 1. You don't see anything before the variable, it tells you that there's 1 there. If you have 5x to the 6th power, the coefficient is 5. Then there's also one unique thing about a polynomial, which we call the degree. So let's look at the degree. First off, let's look at the degree of a term. So we've already talked about what a term is. So degree of a term. This is sum. This is the sum of the powers of the variables in the term. It is a sum of the powers of the variables in the term. So note that if the term has only one variable, then the degree is the power of that variable. Okay. Let's take an example here. If you have 2x to the third, the degree is 3, because we only have one variable in this term, which is x, and so the power there is the degree. If you have negative 3xy squared, the degree is also 3 in this case. It's also 3. And this is because in this case, we have 2 variables in this term. The degree is 3 because, let me put it this way, because x has power 1 and y has power 2. And from the definition of the degree of a term, we said that it is a sum. So the degree is going to be the sum of these 2 powers, and that is 3. So that is the reason why for this particular term, the degree is also 3. So let's say this is 1, that is 2. Let's look at this one here, 4x squared y squared. Here you see that the power of x is 2. The power of y is also 2. So it means that the degree will be 2 plus 2, and that will be 4. Take note of it carefully. Another one, negative 3, x5, y3, and let's say z4. So take note of it. The degree will be 5 plus 3 plus 4, and that will give you 12. So when we sum up all the powers of the variable, that will give us the degree of the term. Now, if we know the degree of a term, then we should be able to deduce the degree of a polynomial. Mind you, we said that a polynomial is a finite sum of terms. Finite sum of terms. And so if we know the degree of a term, we should be able to come out with the degree of the polynomial. So let's go to the next page and let's talk about the degree of the polynomial. Of a polynomial. So note that, so recall that a polynomial is a finite sum of terms. Okay. Polynomial is a finite sum of terms. In other words, every polynomial has some number of terms that constitute their polynomial. And so if we know every individual degree of the terms, we should be able to use those to deduce what the degree of the polynomial is going to be. Okay, so here the degree of the polynomial is the greatest degree or the largest degree. The greatest or the largest degree of any non-zero term of the polynomial. Okay. So because we know that a polynomial is made up of what? Terms. What we're going to do is we have to look at individual terms and their degrees. The largest of them will represent the polynomial. Okay. So let me put it this way. To find the degree of the polynomial, to find the degree of the polynomial, all that you got to do is find the degree of the individual terms. And the highest or the largest degree represents the degree of the polynomial. So it is very, very easy, but you just have to be patient, look at all the terms in the polynomial, try to find all the degree of the terms in the polynomial, and then just pick the largest as a representative of the polynomial, and that becomes the degree of the polynomial. So let's look at this example. What is the degree of the following polynomials? First one, I have 3x to the 5th power minus 4x squared plus 1. Second one is x squared y squared minus x squared y plus x squared plus xy. The solution. Let's look at the first one. 3x 5 minus 4x squared plus 1. Let's pick the terms individually. So if I pick 3x to the 5th power, the degree, remember that if the term has only one variable, then the power of the variable is always the degree. So in this case, the degree is 5. If I pick negative 4x squared, same preamble, one variable, so the power becomes a degree. So the degree is 2. And if I pick 1, the last term, because this is a number, because this is a constant, it doesn't have any variable, it tells you that the degree is 0. Please take note. For a number, for a constant value, the degree is always 0. But if it has a variable, then you're looking at whether you have only one variable or you have multiple variables in the term. If you have only one variable, then the power of that variable becomes a degree. If the term has multiple variables, then you're going to pick the degree, the power of every variable there, and you sum them up. That gives you the degree of that term. So in this case, we are looking at this polynomial and we want to determine what the degree is. So first off, we want to determine the degree of every term in this polynomial. And then the highest or the largest degree will be the degree of the polynomial. So we see here that the largest degree is 5. Okay, so that tells me, therefore, the degree of the given polynomial 3x5 minus 4x squared plus 1 is 5. Simple as that. Look at the second one. We have x squared y squared minus x squared y plus xy squared plus xy. We also want to find the degree of this polynomial. So look at it carefully. This is one term, this is one term, one term, one term. So we have 4 terms in this polynomial. And we have what? 2 variables in there, x and y. So because of that, we want to find the degree of every term by summing up what their powers, because we have what? Multiple variables there. So if you look at this carefully, look at just this, look at this, look at that, look at that, you will see that the degree is 4. The degree is 4 here. It will be 4, because when I sum 2 and 2, it will give me 4. Here, degree is 3. X has a power 2, y has a power 1. So when you sum it up, degree 3. Here, degree is also 3. X has a power 1, y has a power 2, 1 plus 2 is 3. Here, degree is going to be 2. Because x has a power 1, y has a power 1. You sum them up, it gives you that. So based on these individual degrees, we see here that the largest degree is 4, and that will be the degree of the polynomial. Therefore, the largest degree 4 is the degree of the polynomial above. So yeah, that will be the polynomial. The degree of the polynomial is going to be 4. Let's look at this example here. Given the polynomial to 2x plus 3x squared minus 6x cubed plus 5x4. Find coefficient of the terms. First term the last term and finally the degree of the polynomial. So let's look at this example carefully. So I have negative 2x plus 3x squared minus 6x 3 plus 5x4. Now, normally a polynomial will not be given like this. A polynomial will always have to start with the highest power of the variable. In this particular example, this polynomial expression has 1, 2, 3, 4 terms, and it has only one variable. The variable is x. So under normal circumstance, that has to be rearranged so that the variable with the highest power in that particular term should come first. But if it is not rearranged and the question is asked, as you see here, it says find the coefficient of the terms. What is the first term? What is the last term? What is the degree of the term? Just follow as is. So here, the first one, the coefficients of the terms are, remember the coefficients are always the value that come before, the values that come before the variable. So we have negative 2, we have 3, we have negative 6, and positive 5. These are the coefficients. And I says that we should find the first term. In this particular case, the first term is negative 2x. By way of what we have here, I know it is not rearranged. By way of what we have here, this is going to be a first term, this is going to be a second term, this is going to be a third, and this is going to be a fourth. But like I said, normally a polynomial will not be defined like that. If it has only one variable, then the highest power of the variable will have to what? Start first. But not in this case. It is now rearranged for you. So just see it as is, right? That is going to be your first term, second term, third term, fourth term. Okay. Second, third question says the last term. Okay, so the last term is 5x4. Okay. The last one here says that what is the degree of the polynomial? Remember, if we need to find the degree of the polynomial, we have to look at the individual terms and their degrees. The largest is going to give me the degree. Okay, so based on this polynomial, this first term here has a degree 1 because the variable x has a power 1. This one here has a degree 2 because the variable has a power 2. This term here has a degree 3 because the variable has a power 3. And this term here has a degree 4 because the variable has a power 4. Now, if you look at all these cases, you will see that the degree 4 is the largest. Okay, so from the polynomial given, the degree of the polynomial is 4. Since the term with the highest degree is 5x4, and the degree we know is 4. Now let's look at how we can add and subtract polynomials. So let's talk about addition. Subtraction of polynomials. We add polynomials or subtract polynomials by way of what we call like terms. Okay, so let's look at like terms. So we add or subtract polynomials by applying like terms. Like terms. So what is a like term? A like term or better still, like terms like term is a term that has the variable raised to say power with other terms. Other terms. Okay. Or better still, if we're talking about like terms, they are terms with same variables and with same powers. So for instance, if we have 3x squared and 4x squared are alike because they have the same variable, which is x, and they have the same power 2. Okay. Three x y squared and negative 2x y squared are like. Okay. If we have 2x y squared and negative 3x squared y are not like, not like terms. And the reason is because even though they have the same variable, x, and then another variable y, the powers are not the same. The power in this term here for x is 1. The power in this term for x here is 2. Now, for variable y, the power here is 2, and the power there is 1. Because the variables in these two terms are not of the same powers. They are not like terms. Okay, so we use the idea of like terms to add or subtract polynomials. Okay, so note we add or subtract polynomials by collecting like terms. Take example. Add the following. X cubed minus 3xy plus 2x 6x cubed plus 2x squared minus 3x. Second one, x squared minus 2x plus 5 and 4x squared minus 2. Now, if a problem is given this way, you can either add it horizontally or you can add it vertically. So first I'm going to look at the vertical form. Let's look at the vertical form. So I'll have, for the first one, I have 4x cubed minus 3x squared plus 2x. And then I have 6x cubed plus 2x squared plus 3x. Remember that the aim will be to add. So this is my plus sign, means I'm adding. Now, if you have a situation like that, it means that the terms are already collected for you. So you see that the x cubes are aligned, the x squared are aligned, and then the term x is also aligned. Okay. So basically, you just want to hold the variable because they are like, and then you're looking at summing up the numbers. This is 2 plus -3. That should give you -1. Somewhere there. And then you also keep the x squared term. You're going to sum up -3 and 2. So -3 plus 2 will equally give you -1. And then you're going to hold the x cubed. We sum up 4 and 6. 4 plus 6 is going to give you 10. Which, if you rewrite, is the same as you have 10x cubed minus x squared minus x. It's the same thing. You have your answer. So this is how you do it in a vertical form. You can equally do it in horizontal form if you want to. So in the horizontal, it's going to be like this. X squared minus 3x. So this is how the horizontal form looks like. So all that you do is you just want to collect terms. So I see x cubed here, I see x cubed there. So I can combine those for x cubed plus 6x cubed. And I also have 3x squared. I have plus 2x squared there. I have plus 2x. I have negative 3x. So you can combine them as such. You should be getting the same result as we did with the vertical form. So here, the x cubed is common. So you pull that out basically. Here, the x squared is common. So it's going to be something like that. Here, the x is also common. So you pull that out, which means that you're going to have, this is giving you 10. And normally numbers are written before variables. So that will give me 10x cubed. Negative 3 plus 2 is negative 1. Negative 1 times x squared is negative x squared. Here is also going to give me negative 1 times x is negative x. And you are all set. This is how you do it. You want to write it as in horizontal form or vertical form. Whichever form is given to you, you should just go ahead with it. The second one, I have squared minus 2x plus 5 and 4x squared minus 2. So whichever way you want to do it, it's fine. I can do it vertically. So that means that I have x squared minus 2x plus 5. And I just want to make sure that I collect terms. So basically, I don't have anything for x. So it's just 0x. And then I have plus for x squared. So this is how it would look like if I'm changing this to a vertical form. Carefully. In this case here, I have the x squared term. I don't have the x term. And because I don't have it, I just kind of introduce a 0 coefficient and the x terms, just so that they'll be aligned. So 5 plus minus 2 will give me positive 3 plus 3. Negative 2 minus 0 is still, negative 2 plus 0 is still negative 2. So negative 2x. Remember that we are holding the x the same because that makes them what? Like. So I hold the x squared the same. That's a 1 here in front of the x that we don't normally write. So if I'm going to sum up, it's going to be this invincible 1 added to 5, and that will give me this result. And I'm done. Okay. What if we are to subtract? For example, subtract the following polynomials. Seven y squared minus 11y plus 8 minus 3y squared plus 4y plus 6 second one, I have 2y cubed 7y squared minus 4y plus 6. I have 14y cubed minus 6y squared plus 2y minus 5. Let's look at how we can solve this. Now, with a subtraction, what you're going to do is to subtract, change the subtraction sign or the subtraction symbol, whichever way, to addition sign, and write the opposite of the terms in the second polynomial. Better so the polynomial on your right hand side. So you have a subtraction, you are dealing with a subtraction here, subtraction of two polynomials. You want to change the subtraction sign. When I talk about subtraction, this one here or that one here, you want to change the sign from subtraction to addition. And once you change it to addition, you're going to change the sign of every term here. Okay, that is what I mean by opposite. Okay, so change the sign of every term here once you change the subtraction to addition, and then you can go ahead. Okay, so the first one we have 4 7y squared minus 11y plus 8 minus negative 3y squared plus 4y plus 6. Okay, so by way of the procedure, what we're going to do is I'm just going to change. I hold whatever is on my left hand side, change the subtraction to addition, and then every sign here is going to change, and this is negative, so it's going to be plus. This is plus, it's going to change to negative. That will equally change to negative. Okay, now that I have it this way, I can go ahead and add up by collecting terms. So add by collecting like terms. Remember what like terms are? They are terms with same variables raised to same powers. We don't consider the coefficients. It's only the powers should be the same, and then the variable should be the same. So based on what we have here, I have y squared here, I have y squared here. It means that I can collect these together. I have negative 11y and I have negative 4. I can collect them together. And I have 8 and I have negative 6. So if you look at it carefully, this is what I have. From here, I can sum them up. I have 7 of the y squared and added to 3 of the y squared. So together, I'm going to have 10. So basically, it's like that. And this is also something like this. Put some plus somewhere here. And then this one here is basically going to give me 2. So that will give me 10 y squared. Negative 11 minus 4 is negative 15 y plus 2. And that will be your result. That's it. Second one, it's just about the same preamble. Two y cubed minus 7y squared minus 4y plus 6. Subtracting 14y cubed minus 6y squared plus 2y minus 5. So it's the same idea. I'm going to keep what is on my left hand side the same. I change the subtraction to addition. And I'm going to change every sign here. If it is plus, it becomes minus. If it is minus, it becomes plus. Plus becomes minus. Minus becomes plus. And now I have an addition problem where I can now collect terms. So 2y cubed, I have y cubed here, so that makes these two to be like. I have negative 7y squared. I also have some y squared here, which is 6y squared. And I have negative 4y. I have a y term. And then I have 6 and 5. So if you look at it this way, that way, that way, that way, we should be able to get our result. We are keeping the y cubed the same. 2 minus 14 gives you negative 12. We're keeping the y squared the same. Negative 7 plus 6 is negative 1. So that we're keeping the y the same. But negative 4 minus 2 gives you negative 6. And then as for numbers, very easy to add up. That gives me 11. And I'm done. So that is how we add or subtract 2 or more polynomials. Let's quickly look at how to multiply. Let's look at polynomial multiplication. So here we are looking at multiplying polynomials. And just as we mentioned earlier, we have 3 unique types of polynomials. We have the monomial, we have the binomial, and then we have the trinomial. So what we do here is we can have a case where a monomial multiplies a polynomial, a binomial multiplies a polynomial, or a polynomial multiplies a polynomial, or a trinomial multiplies another trinomial or another polynomial. So it keeps going on and on and on like that. So the first one that we want to look at will be a monomial by a polynomial. A monomial by polynomial. And here what we do is we distribute. So we distribute the monomial over the polynomial. It's very, very simple. For instance, if you have a case like a monomial is m, a plus b plus c plus d, right? This is the polynomial. And this is the monomial. So here, how do we multiply? We just distribute. Just distribute and we are all set. So if you distribute, you have m into a plus b plus c plus d. Whatever is outside distributes over those inside. Stuff like that. And when you do that, m multiplies a is going to be ma plus m multiplies b, mb, m multiplies c, mc, and then m multiplies d, md. So that's how we do a monomial by a polynomial. Let's look at this example here. Multiply. So recall that the product rule of exponents says that if I have a to the n times a to the n, the result is a raised to m plus n. So we're going to be applying this rule even as we multiply this monomial and the polynomial. Yeah, so we have 2x to the 4th, 3x squared plus 2x minus 5. So think of it carefully. It's going to be 2x to the 4. So note that this is going to go that way, multiply that way. That also multiplies that. And that also multiplies this. Okay. So times 3x squared plus 2x4 times 2x, and then 2x4 multiplies -5. From here, we can always multiply the coefficients 2 and 3, and then we can also multiply the exponents. So I'm just breaking things down for you to see how this goes. X4 and x. And over here is very simple. You just have only one variable with this power. So just multiply the 2 by -5, that gives you -10. And then just attach your x to the 4. Now over here is going to be 6. This is where we use the product rule. Product rule. Remember the product rule. The product rule says that if two items multiply, they have the same base, keep the base the same, and sum the powers. So I keep x the same, I sum the powers 4 and 2, gives me 6. Plus 2 by 2 is 4. And I do the same idea here with the product rule that has a power 1. So if I sum up the powers, it's going to be 5. And then the last one there is just this. Okay, so that would be my answer. 6x6 plus 4x5 minus 10x4. If you have a case like that, you should be able to get the degree. The degree here will be 6, because the highest power, the variable in question is x, and the highest power is 6. So that is going to be the representative degree for this polynomial. Let's do another example. Multiply -3x raised to 5, 2x cubed minus 5x squared. Same approach. The -3x5 is going to distribute over the items in parentheses. So it will go this way, -3x5 times 2x3, -3x5 times -5x squared. Look at it this way and look at it that way. See that -3 times 2 is -6. And then with the x to the 5th power, x to the 3rd power, we use the product rule. So we keep the base x the same, and then we're going to sum up the powers. So 5 plus 3. Over here, we have a -3 multiplying a -5. Two negatives multiply, the result is positive. So in this case, we're going to have plus 15. The x to the 5th power, x to the 2nd power, we use the product rule, we keep that, and then we sum up the powers. So all in all, I'm getting something like negative 6 x to the 8 plus 15 x to the 7. That's my result. So this is how we multiply a monomial. Remember, a monomial is a polynomial with only one term. So if anything, if you're going to multiply a monomial by a polynomial, the monomial has to be outside the parenthesis. It has to be outside the polynomial. And the only way out to multiply will be to distribute the monomial over all the terms of the polynomial. And this is what we see in some of these examples. Let's look at another case where we're doing a binomial, or better still, a polynomial by a polynomial. Let's look at a polynomial by a polynomial. Polynomial by polynomial. So this is the second one. We still distribute one polynomial over the other. It's the same preamble. Okay, so I'm just going to go ahead and do some examples. Multiply so I have x plus 4 times 3x squared plus 4x minus 5. So you can approach it in any way feasible, possible for you. We have two polynomials. Of course, this is a binomial and that is a trinomial. But we just term them as polynomial by polynomial. Now what we do here is you can go from left to right, where every term of this first polynomial has to multiply every term of the second polynomial. Then the second term will also do likewise. So basically, we're going to go this way. Let me use red. The x is going to go multiply that, and it will multiply that, and finally, it will multiply this. Then the 4 is also going to do the same. Multiply that, multiply that, and we'll also multiply that. Okay, so that is how we're going to be doing this one. Let's go. So here, I'm going to start with the red one, x times 3x squared, x times 4x, and then x times negative 5. I'm going to go to the 4. The 4 multiplies that. So 4 times 3x squared, and then 4 times 4x, and then 4 by negative 5. Okay. We're going to multiply this. It's going to give me 3x cubed plus, that will give me 4x squared minus 5x. Remember, what we're doing here is with the x's, we're using the product rule. The powers are 1, 1. So to multiply, I just have to keep x the same and sum up the powers, which will give me 2. Over here, the x here has a power 1. The x here has a power 2. If I'm multiplying, then I use the product rule. I keep the x the same, and then I sum up the powers, and that gives me 3. Do the same for that. This is just going to give me 12x squared. That'll give me 16x, and that gives me negative 20. From here, what I do is I'm going to collect like terms. I have 3x cubed. I don't see any x cubed here, so I keep that the same. I have x squared, and I have x squared here. So just by way of the notes, I just want to regroup them. Just regroup them. The x term also has to be in line with the 16x, and then minus my 20. So see that we have 3x cubed plus 16x squared. Am I getting the 16 from this? 4 added to 12 gives me 16. The x squared is the same, so I keep it the same. Over here, I have negative 5 plus 16. Negative 5 plus 16 is going to give you positive 11. Positive 11. And I maintain the x. And then minus my 20. And I'm done. For another example. Multiply. It's 1 over 5x squared plus 2 over 5. And then multiplying 5x cubed minus 10x squared plus 20. Same idea. The 1 over 5x squared will multiply every term here. 5x cubed, 5x squared times minus 10x squared plus 1 over 5x squared times 20. Then the 2 over 5 will also follow suit. 2 over 5 times 5x cubed, 2 over 5 times minus 10x squared, and then 2 over 5 times 20. Look at it carefully. If you look at it carefully, 1 over 5 times 5 is basically 1. X squared times x cubed will give you x to the 5th power. So that will be x to the 5. If I come here, 5 goes into -10, -2, and then x squared times x squared will give you x4. Here, 5 goes into 24 times, so it's just going to be 4x squared. If I come here, the 5s are going to cross out, so I will be left with 2x cubed. Here, 5 will go into -10, -2 times that will give you -4x squared. 5 goes into instead of 1, it goes into 24 times 2 will be 8. So all you do will be to now simplify by collecting terms. So let's go to the next page and I'll do it there. So I have x cubed, x to the 5th power, 2x to the 4th plus 4x squared plus 2x cubed. Just rewriting what we did before, 4x squared and plus 8. So what I need to do here will be to check to see if I have any like terms to collect. I have x to the 5th power. I don't see any x to the 5th power anywhere. So that has to be maintained. I have x4 here. I have x. I don't have any x4, so that maintains. I have x squared here. I have x squared here. They are of the same coefficient except for the signs. They will easily cross out. So this here is going to cross out that. And then the rest of it will just be our answer. So x5 minus 2x4 plus 2x cubed plus 8 be our answer. Then we have the FOIL method. FOIL method. FOIL method. But everything else that we've done, especially with the polynomial by polynomial, is centered around the FOIL method. Okay. So what do we mean by FOIL? FOIL is just coming from this one here, says the first. This one here is just the outer. This one here is the inner. And the L there stands for the last. Basically, the first term is our terms, right? Outer term, inner term, and then the last term. So if I have a typical example like A plus B times C plus D, we have to apply the FOIL method. Apply the FOIL method. Here, This is the first. This is the this is just going to be the last. So this is the first, this is last. So last, first, last. And these two here together will be what we call the inner. And again, these two here are considered also as the outer. Okay. But in all, it's all about distributing. So A plus B, C plus D, is about distributing. Okay. The A here multiplies that and multiplies that. And the B is also going to do the same. So it's a very simple concept, just as we saw earlier. So the A multiplies the C and the D, and then the B will also do the same. Okay, so from here, A times C is AC, A times D is AD, and then we go to B times C, BC, and then B times D, BD. That gives us a result. So a typical example is to multiply x minus 2 and x minus 6. So the same idea. The first term here multiplies everything. So the x into x minus 6. Then the second term here, which is negative 2, also multiplies x minus 6. So from here, what we do is we distribute this and this. And this, and this and that, and this, and that and that. So just multiply, and we should be all set. X times x is x squared. X times negative 6 is negative 6x. Negative 2 times x is negative 2x. Negative and negative is plus. 2 by 6 is 12. Now you can simplify your answer by checking to see if you have some like terms in there. Negative 6x and negative 2x are like, so we can sum them together. Negative 6 minus 2 is negative 8x plus 12, and we should be all set. So another example. Multiply 5x minus 6, and then 2y plus 3. Same concept. 5x minus 6, 2y plus 3. So this 5 here, x, is going to multiply everything here. So 5x multiplying everything there. And the negative 6 will also do the same. Multiply everything there. So from here, we just distribute, and we should be all set. 5 times 2 is 10. The x and the y will multiply, it will give you xy. 5x times 3 will give you 15x. Over here, negative 6 distribute through, negative 6 times 2, negative 12y. And then negative 6 times positive 3 gives you negative 18. Again, you want to check to see if there's any like terms you want to collect. Otherwise, you should be all set. By way of what we have here, there are no like terms. And so we settle for that as our answer. Do one more and all set. Multiply. Very carefully. Here we have 3 items multiplying. The one outside is a monomial. Anytime it's a monomial, we don't put any parenthesis anywhere. But when you look at these two here, these are binomials. So there's a need for you to put a fence around anything that is bi or tri. Better to put them in a parenthesis. You have 3x cubed into x minus 2 and 2x plus 1. So what I'm going to do is I'm going to tackle this first. I'm going to keep my 3x cubed. Tackle this first. Every item here has to multiply that. So x by that. I'll put a parenthesis or bracket. And it's going to be x times 2x plus x times 1. Then negative 2 multiplies 2x. And then negative 2 multiplies 1. And from here, we are keeping our outside item. It's going to be 3x cubed. Now, this 2 here multiplies will give you 2x squared plus x. That will give you 4x. And that will give you minus 2. Okay, check how I multiply everything. And then I'm still going to keep that and simplify what is inside. 2x squared. And when you get here is x's. So x minus 4x should give you minus 3x minus 2. And now I'm going to distribute. I'm going to distribute through here. Yeah, that's here, that there, and that there. So if you do that, it will be 3x cubed times 2x squared plus 3x cubed times minus 3x and plus 3x cubed times minus 2. Look at the way things are written here. 2 by, so we are looking at this way, we're looking at this way, and we're looking at that way. So give me 6 x to the 5th power. Remember, we are adding the powers. And then minus 9x raised to 4. And then minus 6x to the 3rd. That will be your result because we don't have any like terms here. So that is going to be our result for that. And we should be all set. Let's look at what we call the square binomial. Square binomial. Or sometimes we say binomial squared, square binomial. Remember what the bi is? Bi is 2 terms. Okay, so 2 terms that are squared. 2 terms of a polynomial squared. So basically 2 terms of a polynomial squared. Okay, for instance, if I have a plus b, these are 2 items, so I square. And this is the same as I write a plus b and then a plus b. Remember, under exponents, the power tells us how many times the base has to multiply itself. The power is 2, the base is a plus b. The 2 tells me that I should multiply the base twice. From here, I just use the FOILing. A multiplies A multiplies B multiplies A, and B multiplies B. Okay, so if you want, I can still use, just to illustrate to you, A multiplies A multiplies B, and B will multiply A and multiply B. So just to the page. Let's go to another page. So we have A plus B all squared. This is what we had, A plus B, A plus B. Just like we did before, A times A. We have A times B. We have B times A. And then we have B times B. Do that, this is going to give you A squared plus AB plus AB. Alphabetical order, A comes before B, and B squared. Now, from here, we realize that these are like. So a squared plus, I have 1ab plus another 1ab. I'm going to have 2ab plus b squared. And this is what we call the binomial squared. Binomial squared. So it's pretty much very simple to analyze. What it says is that you have two items, a by, a and b, are squared. So if you look at it carefully, the a, which is the first term, has to square, which is this. There's going to be a middle term. That middle term will be when you pick these two here, multiply by your first term and your last term, which is 2ab. And then finally pick your last term and square it. That gives you your b squared. So if I'm using that as an example, then pretty much I will have something like this. Say x plus 2 all squared. That's an example, right? Here, I can break it off as x plus 2, x plus 2, and then just do a foiling, so that I will have x times x will give me x squared, x times 2 will give me 2x, 2 times x will give me 2x, and then 2 by 2 will give me 4. These two here are like, so I'm going to have x squared plus 4x plus 4, and that will give me my answer as you see here. Okay. So this is pretty much very simple. To another example. Multiply and simplify. Your result. Two x plus 1 all squared. Two x plus 1 all squared is pretty much very simple. The first term has to square, so 2x has to square. There should be a middle term that will be these two here, multiplying the first term and the last term. Then finally, the last term also squares. Based on the rules of exponent that we talked about, this is the product of power. That means that the power gets distributed over this. So this is just going to be 2 squared, x squared. Over here, we just multiply everything. We're going to get 4x. And then when you square 1, it's still 1. And when we combine the numbers, this is going to give me 4x squared plus 4x plus 1. So it's not too bad. Just do one more. Simplify. Five R minus 6s all squared. So here you have to note carefully. Five r minus 6s all squared. Remember the rule, the first term has to square. So 5r all squared. There should be a middle term that will be this 2 times whatever is in your first term times everything in your second term or the last term. And finally, the last term also squares. From here, we are still using the rules of exponents. These 2 distribute over that. So this is going to be 5 squared is going to be 25. So basically it's going to be 5 squared, 5 squared. Over here, we're just going to multiply all the numbers. 2 by 5 is 10. By that is negative 60. And then we just attach the r and the s. Over here, negative 6 squared will give me positive 36 and x squared. So together this is going to give me 25 r squared minus 60 rs plus 36 x squared. And there are no like terms to collect. That means that is your answer. I hope this helps you out. Thanks for watching.